Our project is enhancing erosion resistance in photopolymer resins through the incorporation of linseed-filled microcapsules. So some more background on nanoencapsulation. It takes two polymers and puts them together around the filler, which our filler will be linseed oil. And we are going to use urea and formaldehyde to make these capsules. Some background about resin 3D printing. It's a 3D printing technique that uses ultraviolet light to cure photopolymer resin, and it offers immense detail. However, as we see, it's very fragile and susceptible to erosion. Previous studies have covered a topic like this. They incorporated nanocapsules into epoxy resin, which is more of a coating, and our project aims to explore the possibilities of using it as a manufacturing material. Like I said, the gap in knowledge is nobody's done it before with photopolymer resins to be used as a material to build parts and pieces. Our question is, can linseed oil nanocapsules increase erosion resistance in resin 3D printing applications? And then we hypothesized if there are linseed microcapsules present in resin 3D prints, then there will be an increase in erosion resistance. Some of our variables are the independent is going to be the prints and benchmarks with and without the urea formaldehyde nanocapsules. And what we're measuring is the weight loss every day throughout a week.
These are the materials that we used, including a lot of the chemicals for the urea formaldehyde microcapsules and all of the materials that were used in collecting the data. So for the safety, we're using a lot of chemicals that could harm us. So we're making sure to use a fume hood, gloves, long sleeves, and make sure none of our skin touches these chemicals. And then for disposal, we're just giving it to the county and they are disposing it from there. We started our experiment with the synthesis of the urea formaldehyde microcapsules. Then to store the microcapsules, we put them in a solution of xylene and water, so if they burst, there would be no reaction. Once we stored them, we got the resin, did the control group by 3D printing them and then putting them in a rock tumbler for 5 days. Then we went back, put the microcapsules through a filtration device, and then put them in the resin at 11% weight. We then printed out our cubes again and repeated the process for this next batch. And then for the cleanup, we just made sure all the chemicals were in a safe, airtight container and that all of our other gloves and droppers were disposed of properly. Here is the raw data for the control group that did not have the urea formaldehyde microcapsules. These are the results for the UF microcapsule group. The top is the raw data of the weight at each day, and then the bottom is the percent decrease in mass over those 5 days also. So here are the graphs that we have. As hypothesized, the microcapsule group had an increase in erosion resistance over the 5 days, and these results are statistically significant. These findings offer real-world implications, creating more uses and environments for resin 3D printing, such as in aerospace and naval applications. One strength of our experimental design is that we did a lot of research on the synthesis of the formaldehyde urea microcapsules and followed a lot of in-depth guides on how much the temperature, the time, and everything for the synthesis. It took an entire day, but in the end, we got very accurate results that other scientists, other peer-reviewed scientists have done, and it has worked for them. However, one weakness of our experiment is that we only use one trial per group. Using more trials could get us more averaged results, which could then make it better for the real world application and decrease our standard error.
And to end, a big thank you to Ms. Strauss, our chemistry teacher, for supervising us and helping us order the chemicals that we needed.